Okay, so today we have our guest Majid Zamani, and do you mind to introduce yourself?
Yeah, I'm Majid Zamani. I'm an associate professor at University of Colorado Boulder, and I'm glad to be here visiting Kai.
Thank you for coming, and I'm sorry that I couldn't find funding to support you here. And you are doing your sabbatical, right?
Yes, I mean this August is finishing.
Okay, but where did you go so far?
I mean, it's been hard with the family because my daughter, she does competitive dance. So what we were able to do last summer, I visited Antoine Girard.
Yeah.
You know Antoine,
okay.
right?
Yes, I do.
CNRS for a month, and actually one of his students now coming to visit me as part of that collaboration we did. And right now I'm spending 1 month in Japan visiting you, and then I go to Tokyo. I give 2 seminars there as well.
So not only University of Tokyo, you're going to a different place?
Yes. Which university is Hasu?
His place is NII. It's National Institute of Informatics.
Yes, National Institute
You're going
of Informatics
to visit him
as well. Yeah,
okay.
Yeah.
So send my wishes to him because I met him last week.
I will tell him and Ishi as well.
Yes, please. All right, so can we talk a little bit about your research?
Yes.
So what is okay, I know you're working on many things, but tell us the topic that you are most passionate about right now.
I think one topic which I'm very interested now is the idea which we talked a little bit about transfer learning in the context of control. So what do I mean by that? Let's say you apply any existing techniques we have developed in control theory to ensure safety of a system, right? Either using, functional certificate like barrier or discretization-based approaches. So the question of interest is, let's say I have a system, we call it source system, right? For example, a simulation environment, right? You have access to plenty of data. You just run the simulation. So you can collect data, you can actually train your, safety certificate, and you can reason about the safety of the simulator, right? But then this simulation is representation of an actual system. So can we claim that the actual system is also safe? Of course, the answer is no, because there is always a gap from simulation environment to the real system. But then what we are trying to do is, can we use the learned safety proof from the simulation environment, right, which we call it source system, and then collect a few amount of data from the target system,
right,
and being able to transfer the proof to the actual system. So that's what I mean by transfer of guarantee. Of course, here I talked about transferring the proof of safety, but of course the question can be also, can we transfer the learned controller from simulation to the real system? But the key is, of course, you don't want to learn the controller from scratch for the target system, because you already learned the controller for the source, which is a simulation, right? So you want to use that controller and few amounts of data from the target system and being able to transfer the controller from source to target.
Okay.
That's the idea which we call transfer of controller or transfer of proof. So I think this is actually it's very interesting, and as it can have huge impact in industry application as well.
Sounds incredibly difficult to me, especially when you talk about the sim to real, right?
Yes.
I mean, there are a lot of people, AI, robotics people, they are,
True.
Of course, you cannot collect so much data in reality for the robotics, but they need a lot of data. And so people go on doing very realistic simulations, and they're trying to close the gap as much as they can. But if you have some formal approach that bridges simulation to real, that would be, I can see the impact right there.
I think the key difference between what we are trying to do and what people have done in AI community is we are trying to leverage this idea of neurosymbolic techniques.
Right.
So, for example, in formal methods community, people have already answered this question in a model-based environment.
Right.
That's actually what simulation relation is supposed to do, right?
Yeah, yeah.
And in control theory, people try to learn, simulation function, which plays the role of the relation, right? That's actually, it's exactly the role of the role of simulation relation is for transferring guarantee from a source to target. If source system simulates target system, any specification that source is satisfying, target is also satisfying, right?
Yeah.
So I think using that tool and now bringing with the techniques that people have developed in AI community for efficient. So now I can actually train a neural network to play the role of the simulation relation, right?
Yeah.
So, and there are many techniques out there for training such neural network more efficiently, developed by AI community. So we can actually take advantage of that and being able to train this relation.
Okay. Well, very intriguing, because that's another, let's say, approach that I think what we do can make some impact in the AI community. Talking about AI, let's talk about a little bit about how everyone's using AI, especially even lay people for doing their regular work every day. We too, I suppose personally, I have 3 subscriptions to OpenAI, to Claude, and also to Gemini. So they impact my way of working. I wouldn't say in a fundamental way, but obviously I'm working a little bit differently than before. I think if I look back, I tend to use them way more than, let's say, half a year ago. So how about yourself? Are you using them increasingly? Maybe the question is not are you using them increasingly, it's how you probably see how these things will influence your way of doing research, and also maybe influence your way of teaching students. Do you have can you share some of your thoughts on that respect?
I mean, the one way I'm using AI a lot is for logistical task. I tell you exactly what do I mean by logistical task. Let's say old days I used to make a diagram in LaTeX using Tixi.
Okay.
I used to spend 1 day to program a figure or a diagram. So now exactly I just draw it on a piece of paper, I take a picture, I upload it on ChatGPT, and it gives me the code right away. Right? So it's mind-blowing. I don't need to spend, and I don't miss spending time on building that Tixi file on myself. So these are by logistical thing. Even when I do some collaboration with colleagues, sometimes we write on whiteboard or on notebook handwritten equations, right? So of course I can manually put those in LaTeX myself, right? Or I can just take a picture, feed it to ChatGPT, and it gives me a nice LaTeX code, right? So I use AI a lot for those things. So that's about the logistical task. So regarding research, I mean, of course, I ask questions, right? So, let's say if I'm not too familiar with some topic, so I go ask questions and ask for references, right?
Yeah.
So I think it does a good job to expose me to articles or textbooks about the topics that I would like to study, and it put me in the right directions.
Right.
So that's also a great use of AI in my research as well. And I even encourage my students, just you can ask questions and then read the answer and analyze it and understand it. Is it follow the references that it provides? Is it interesting or no? So it's a good starting point.
Right.
So regarding teaching as well, right? You said the students.
Yeah.
Okay, that's an interesting part. So, okay, I teach advanced data science for undergraduate, and as you can imagine, almost all my homeworks are Python programming for any of the algorithm I cover in the class, either clustering or recommendation system, right? Or community detection. And so of course the students can easily get the code from AI. This is what I do recommend to a student to do. I said it's okay to use the AI, but not use it to generate the code for you. What I do recommend you to do is ask AI to give you a flowchart or a pseudocode of the algorithm that you're supposed to code it yourself. And what I want you to do is study the flowchart or the pseudocode and understand it. Does it make sense? And then try to implement it yourself.
Okay.
So rather than blindly getting the code that has been generated by any of these AI model and then running and submitting it, right?
Yeah.
Because at the end of the day, you are here to learn the algorithm and the methods.
Yeah.
And you're spending your time attending my class for a semester, and eventually you're supposed to get a degree and either continue with your education or join an industry. Independently of any of these tracks, if you don't understand this topic, you haven't done yourself a favor. So
right.
And this is what I always tell them.
Okay.
Try to get the flowchart, pseudocode, and understand it, and then implement it yourself.
That's, that totally makes sense to me. However, let me push you on that a little bit. When it comes to evaluation, what I understand you talked about was that your suggestion to the student, right? There's no way we can, as lecturers, we can never verify, in the end, the students used the AI for what?
Unless there are cases that we've been able to discover.
Right.
We've seen few students all did the same mistake. Very silly mistakes, but all the same.
Yeah.
So then we came to understand that actually they used one of the AI model to generate the code.
Yeah.
But I agree with you, in general, it's very hard to detect.
But these are college students. They should. I think what we can provide is the advice like you did. I think, and then they're adult enough to make the judgment by themselves.
And also, look, in US, they are paying out of pocket for the tuition.
And a lot.
And it's a lot. Yeah. And the time that they spend. Time is also, important.
Yeah.
And at the end of the day, they are supposed to get a degree. Let's say they want to go industry. They're going to use that to be able to be successful in the industry interview, right? And industry interview for industry jobs are becoming more and more difficult. Like many layers of interview, like we are talking about 7, 8. So if you have used AI and you haven't understood any of the topic, so of course it's going to be hard to pass any of those interviews. So meaning that you're not going to be able to secure a good job with a degree that you spend a lot, both money and time. So I tell them they are not doing themselves any favor by not understanding,
Right.
So that's, I think at the end they're going to lose an opportunity by using AI a lot.
By the way, have you changed the way you evaluate students because of AI? I'm asking because let me tell you what my story is. I used to, even for undergrad, if it's a third year, fourth year course, I try to encourage students design take-home assignment in the end, rather than doing the in-classroom test. I try to replace in-classroom test to to be something more exploratory for the students to do some research on their own. However, I'm finding myself getting the same, as you just mentioned, making the same mistake. I give you an example. In one of my control course, in the final assignment, I ask the students to do many things, and I add one more thing, design a simulator for, I think it was using a drone to balance a pendulum or something like that. So the assignment asked them to design the whole package, but I have a bonus point for people who can design also a simulator. This was 2 years ago. Of course, the performance of those LLMs are not as good as today. So I didn't pay too much attention to the design of my assignment. I got like, I don't remember the exact number, like 7 or 8 simulators exactly the same.
The same.
When I run them, like, I didn't. First of all, I only expected maybe just 1 or 2 students would spend the time. I do say that I give extra points if you can do this, because I'm thinking this is probably taking quite a lot of time. But I got so many. When
Was
I
it
run,
in Python or MATLAB? MFile.
actually, quite different varieties.
Okay.
So students obviously use them to prompt different coding language at the end. However, when I run them, okay, the first student I run, it looks great. Like, okay, it's working. Then I started to mark, right? I give like A++ or something like that. But then I started to run the second one. I realized it's quite similar to the first one. I started to run more. Okay, not all of them are the same. But many of them, I would say like 70% of the simulators I received in the end look quite similar. And at that time I realized, okay, probably I probably need to change the strategy of not heavily relying on this evaluation, only on the take-home assignments. So right now, I still want to keep that. So right now what I'm doing is kind of hybrid. I'm doing one in-classroom test, like usually midterm or between midterm and the final. And for the final, I still do an assignment. Yeah, but I do require students to make every single citation to the places where they use the AI.
Even if they use AI.
Yeah. That's my approach. Sorry.
I mean, let's say I'm in my courses.
Yeah.
So one of them is a graduate level. It's about foundations of autonomous systems, which topics are, very new, even in terms of research. So there are not that much information is still available to the AI models to be able to get, and many of them, they need to do project. So it's not like a scientific or textbook questions that they can put in AI, and there are sequence of activity they have to do. So that's about the graduate level. The undergraduate level, unfortunately, it's okay. It's we provide them with a lot of data set which they need to program any of the algorithm. So that, of course, they can use AI to generate the Python code. I have 2 midterm, but they are take home. I assume they can use AI to come up with a solution for those. But then there is a presentation component to their final project.
That's a good one.
So so we ask questions during their presentation, and we can tell if they have done the project themselves or not.
Right. Presentation is a great way to see really
if they understood.
Exactly. Okay, let me shift to a different question. You just finished your term as the chair for the TC, the Technical Committee on Hybrid Systems for the IEEE Control System Society. You finished the end of 2025, is that correct?
Yeah, December 2025.
Now it's June, okay, yes.
From Waterloo.
Yeah, actually I'm receiving emails. I mean, it used to be you, and now June. So you've served for 6 years, 7 years?
6 years.
2 terms, right?
2 terms, yeah.
So maybe two questions. One, have you seen some obvious shift in the hybrid system community in terms of, let's say, research topics?
A lot.
Or other things. Second is there anything as a TC chair you think, I mean, if you are given another term, let's say, you would like to do? Let's say you missed doing that while you were chair.
So regarding the first question, yes, there is a huge shift. Like we could see, because I need to compile the Control System Magazine article. Each TC, after every 1.5 years, we need to report about the activities.
By the way, I know that as well, because
you used to be the TC
I
chair
did
for DS.
discrete event systems. Yeah.
So I have to compile summary of the activities we have done, and surprisingly, like I could tell from, there was a huge shift from, let's say, 5 years ago, 6 years ago to recent years. The nature of the topics that colleagues in RTC are doing has changed a lot. So I give you a concrete example. For example, many sessions on data-driven techniques.
Okay. Yeah.
Very popular.
Very
a lot.
Yeah.
And many sessions on neural networks and control combined. Many sessions on Gaussian process regression.
Right.
In the context of formal methods as well.
Right.
So like this has changed a lot. Like I'm talking about like many sessions. It's not like within, let's say, one conference, let's say American Control Conference or IEEE Conference on Decision and Control, like several invited sessions or even workshops on that. Or even a special issue within journals on these topics.
I see.
So that's one thing I realized. So regarding the second component of your question, that if I've been given another term as a TC chair, what would I do now? I think what I wish I could have done more is having more, let's say, not workshop, I would like to say like big seminars to bring two community together. Like in our community, of course, classical hybrid systems, from computer science community, people on formal methods, and then also from AI community, right? And we did some, we tried to have those seminars. We were not successful. But then I understood the reason it was not successful. But by the time which I reached to a point that I said, okay, now we can actually have a strong one. So my term was already finished. So
can you share the reason why you realized that was difficult to do at the beginning?
I mean, I guess we were not being very in the beginning. We were in our comfort zone, right?
Okay, I see.
The proposal we were proposing was still not too visionary. I mean, we were trying to stick to the true definition of hybrid system. That's defines our TC.
Our core, yeah.
Exactly.
Yeah.
So we were too using our core as hybrid system. And based on that, we were trying to propose, the list of people we would like to have and the topics that we would like to cover in the seminar. But then the problem was many of those topics has already been covered in other places.
That's it.
As a seminar, workshop.
Okay.
So we need to have quite a new angle to this seminar, which, after some try, then we realized, we need to bring a new angle and component to this. And
I see.
By that time, it's already...
But when you say seminar, is it like online seminar series kind of thing?
It was like a Dachschule type seminar.
Okay.
Yeah.
Okay. I see.
Like you can have 40...
It was not accepted, you say?
Yes.
Okay. I see. You can try the closer one, right? In Banff.
Canada.
In Canada.
Yeah.
They also have...
but I mean, it's not easy. It's competitive.
Yeah,
I mean,
of course. I know that.
Yeah.
We can try one perhaps in the future too.
Yeah, I mean, that's also another... I tried one time. It was successful when I was younger and when I was in Germany.
Okay.
So like the topic I proposed was new, right, at the time.
I see.
And I think the topic we were trying to propose was okay. It came across as union of several topics, which has already been parts of it has been covered in previous seminars. I think we needed to come up with something totally new for the Dashto, something that they say, yes, this we haven't had a seminar, and the group of people you are inviting, it actually will add something. And
I see.
so I think by now I know how to which topic to pursue and increase the chance. But I mean, I really loved. I attended one time.
Okay.
Great place.
Yeah.
I enjoyed a lot.
Yeah.
And I'm actually going next year. I was invited for a doctoral seminar, and I'm excited to go.
Nice. Next year, 2027, you mean?
2027, yes.
Okay. Well, still quite a few months
Yes.
to go. All right. So I introduced to you that we have currently this GST Aspire project, and the topic, at least at the time we proposed, is what we call from natural language to safe actions. The word safe is deliberately added to emphasize that that's somewhere we could contribute our expertise. Although the people we assembled, at least at the proposal stage, were all from control community. So at least I can say Lacroix Pavel from University of Toronto. She is game theory and control theory, network control. Myself, more on discrete event systems, but I also have worked on multi-agent systems. Chu found, okay, of course she started in control, I believe, but these days she's more on large language models, VLM, visual language models, things more towards the AI side, I would say. So I found that could be a nice combination of bringing, people who have expertise from the language, AI, and machine learning, all the way down to multi-agent system control. So the picture we had is that, for example, if I have 3 robots working, waiting for being tasked to bringing books around or coffees around. Traditionally, we would maybe issue a command, and that command gets translated to their motions, and they start to move and do their thing. And that part is more on the cyber physical side, because you have basically a planning. You have multiple agents. You still need to guarantee safety, eventually bringing things to you, things like that. And also you have the continuous movement of these robots. This project, we are trying to build one more layer on top of the cyber physical systems, which is the AI layer, which basically our idea was to use that as a interface between the cyber physical system and humans, so that the humans can talk to the system through natural language, and then everything in between. We know what's going on inside, however, it can be sealed as a black box to the users. And that could potentially increase the usability of such systems greatly, because now if this system is in place, then people don't need any expertise in understanding the inside. You can command a multi-robot system using a natural language. Of course, you still need to speak your natural language in a logical way, I suppose. So that's a project. And I know you are not exactly working on that, but do you think there's anything that, or how do you see this kind of topic?
I mean, this actually is being, I've seen a lot of people now start working on how to translate natural language to, more on the regular language, and be able to extract, formal language out of, the like English text, right? I think this is great, and because usually you are familiar with linear temporal logic, right? Mm-hmm. These are formal and unambiguous way of representing requirement of interest, correct?
Yeah.
But the problem with linear temporal logic is if you go to a factory setting, you cannot expect everybody be familiar with linear temporal logic, right?
That's the same, yeah.
And you cannot tell them that, okay, now you need to go and educate everybody to understand the logic and being able to express the requirement of interest using those logic, right? So I think it's very interesting to have this interface that people can just freely talk with English sentences, and this higher level, this AI module will translate that to a formal language, for example, linear temporal logic, and then this linear temporal logic will send to the planning section, and then the rest will be done by the CPS
we already
layer,
know.
right?
Yeah.
So, of course, there has to be a feedback from the module that does the translation of English text to LTL with the user.
Right.
Because sometimes user might say something, but they mean something else.
Exactly, yeah.
So, and this interface with the user needs to, in the form of feedback, to ensure, do you really mean something like this?
Yeah.
And because, at the end, you might come up with a formal language, which might not be what the user expected.
Exactly. So that's often called a semantic disalignment.
Yes.
Yeah.
Between the user and the
AI translation. Yeah,
of the regular language.
In fact, I expect you to touch upon that point. In fact, one of the interesting things we are proposing to do within this framework is the feedback. However, the feedback you are talking about is one feedback we are thinking of. There's another feedback we are trying to embed in this translation, which is an automatic reprompting mechanism for the LLM or VLM before it even gets back to the user to say, is this what you mean? If so, I will execute it. And right now, those coding agents sometimes do that, actually. Yeah. They confirm before they actually
execute,
do the thing.
Yeah.
But the feedback reprompting, what we call, is before that. Namely, you do a translation. So you provide a natural language. And then you get this LM to translate it into, let's say, LTL. Now, this part is going to check about safety. So it doesn't check anything. Like, it's not for general purpose. But let's say if this is some multi-robot systems, or if in your environment you have an area you don't want these robots to get in. At this point, actually you can already start to do some checking about safety without even asking, before you even ask, is this what you really mean? Because the translated formula might already contain some part
that the user might not even ask explicitly.
Or if it gets to the planning stage, it will plan a path that's going to be unsafe.
I see.
So this, what we try to do is to have a kind of a safety filter to check that.
Before going to the planning.
If we find already, if this plan is going to be unsafe, then we will send it back to the LLM, tell the LLM, your translated LTL will result in unsafety, and this is exactly where the unsafety will occur. We tell the reason, we tell you're wrong and why you're wrong, and try to eliminate this. So that part we think can be automated. Now, of course, if safety is confirmed, then we still need to feedback to the user to check, is it really you mean?
Is that what you want?
So we had two layers of feedback in mind for this. So sorry, we were talking about it a little bit details, but this is basically more with a collaboration with True. It's going to be with True, not Lacra. I think Lacra is, I don't know how much she will be interested in this, but I will definitely introduce this to her as well. She will be visiting me in August. Okay, so I think we've spent quite a lot of time talking about this. Maybe I will close this with one last question to you. It's going to be a tricky question.
Okay.
If you had a second choice, would you still choose to work on this community, namely systems and control?
Yes. In fact, okay, control theory. When I was undergraduate student, we had control theory as a subfield in my undergraduate.
Okay.
So in our undergraduate, I could have choose communication, circuit, power, or control. And usually, let's say good students, they choose between communication and circuit.
Okay.
They were more interesting, right? Communication, because information theory and the courses also we were taking for communication, they were more interesting, you know, and PM modulation, FM modulation, signals and systems, and they were very interesting courses, right? So control theory, we got exposed with the linear feedback theory, frequency domain, right?
Okay. Yeah.
So so it was, until I don't think I took any course in time domain actually during my undergraduate.
Oh, okay.
So maybe one course on time domain, which we call modern control, state space realization at the very end.
Okay.
So I was fascinated by how, if you recall, it's a bunch of boxes with the arrow connected to each other, right?
Block diagram, they call it.
Yes. And I was in electrical engineering, right?
Yeah.
I said, wait, what? There is no I'm in electrical engineering and then I'm studying something which is block diagrams with the arrow connecting blocks, like a feedback and a plant and then we are able to use mathematical tools I don't know if you remember Ruth Lucas.
Yeah, of course.
So
I'm not teaching that, by the way, in my course
Yeah,
anymore.
I know, but it was very interesting to see that how, as an example, we were given a system and we were told that, look, this represents, for example, an airplane. And then this block underneath is the controller that's supposed to stabilize the airplane, right?
Yeah.
And then we were using some, using some tools which, from math, from system theory, signals and systems, and we were able to use those to answer the question if this controller makes this plane stable. And that was fascinating for me, right? I said, wow, this is at that point was the most abstract topic which I studied at that point, right? It was very abstract,
except for mathematics, of course, but
yes.
in engineering you wouldn't
but this is an engineering problem. You've been told this box represents an airplane, right? It's of course, it's a bunch of mathematical equations in it's in the Laplace transform, and I was fascinating that we can use these tools in our disposal and being able to answer these fundamental questions about these complex systems without even need to know the physics of that complex system, because at the end, when you bring the problem to this high level of abstract, so then it's all become you can actually borrow tools from math to be able to answer that question.
And then you just turn the mathematical crank.
Exactly. So that was fascinating, and I decided from my undergraduate I do study control theory. But then later on, it's now of course master, and then I come to the PhD. So, but then I realized that was a great choice, because then I'm in US, and I see people in control theory, they are solving problems in different domains using tools from control theory, like biology,
Right.
traffic network, power systems, you know, air traffic control, and
Anything you can think of.
anything you can think of. And now people are using control theory in the context of LLM.
Yeah.
So, and it was like, it's very fascinating to see that we are working in a science that can easily, with a layer of abstraction, to get adapted to a different domain and expertise, and being able to solve problems to a different domain.
Yeah. It's
And
not
that's-
only the width, but also the evolvability.
Yeah.
Anything basically you can interpret as a dynamical system.
As a system, you
use
can
it.
analyze it.
Yeah. LLM, obviously, you can view it as a dynamical system.
Yeah.
So why not the control?
True.
And they need to be controlled.
Exactly. And that's what I was fascinated then,
Yeah.
and I'm still fascinated now.
Okay.
And no, I think I'm very happy with my what I chose, and I'm very excited to be in control community.
Okay.
Yeah.
On that note, I totally agree with you. And you reconfirmed that I'm not making a wrong choice either. So, on that note, thank you very much.
Thank
Majid.
you.